Namaskar my dear friends. Let us try to understand how to design microcontroller circuits. So in this particular course we will try to understand how we can design Texas Instruments microcontroller. So one of the example that I will be taking in this particular course is MSPM0L series. MSPM0L series. So with this particular session you will be able to design any of the number of pins that is there in this particular series. One of the specific example I will take it is 20 pin microcontroller. However, you will be able to design up to 64 pin microcontroller in this particular series. Okay. So let us say a snip of the circuit that I have given it here, that this is my microcontroller and there are peripheral circuits that are attached to it, like we have push button switch or maybe an NRST pin, we have programming connector, we have power supply. So how to do or how to start with all these design, that we will see one by one. So before that, let me list out the contents that we will be covering in this particular course. So we'll try to understand how to select microcontroller. Then we'll go ahead with one of the selected microcontroller. Let us say we are going to work with MSPM0L1105. So let us say we have already selected this. So now we will be seeing the device details, features and resources that is available to develop applications based on this microcontroller. And what are the different applications that this particular microcontroller can be used for. So that's the main thing, like you will be able to utilize in those kind of projects. Then we have device development resource as well, like the Texas Instrument itself gives you lot of evaluation board and source codes and all those things, so those you can utilize. Then we'll try to understand the microcontroller functional block diagram. Now if we go to our system design, then we'll understand system block diagram. That will be our first step of designing the microcontroller based schematic. Then we will see schematic entry demonstration for each of the circuit section, and we will develop bill of material and PCB layout design guidelines also I will give you, like how you can put microcontroller, where you should put like power supplies, or where you should put all the other peripherals that you will be having in the microcontroller schematic section. Then I'll also give you a process of having assembled PCB or testing procedure, and then a little bit of programming procedure, like how to start programming, like toggling LEDs or push buttons, reading the push button values, all those things we'll try to understand. Okay. So let me give you an introduction of this particular microcontroller. The part number for this is going to be MSPM0L1105, and once I share this particular material with you, you will be getting all this PPT directly, okay, along with the videos. And this is the product link that I have given directly, so that you can directly get into the product page of this particular microcontroller. Okay, so if you click on this particular link, then you will be getting a microcontroller page which is there from Texas Instruments. So this will be the microcontroller page that is there, and you can get complete information about this microcontroller that is there, like what are the parameters, what is the frequencies and all these things. We have packages, we have features, a lot of features are there that is there, we have descriptions and everything. Okay, let's move next. So as you can see, this particular microcontroller series is for a small consumer or battery powered industrial applications, okay, and it is a 32 MHz ARM Cortex M0 Plus MCU with 64 KB of flash and 4 KB of SRAM with 12-bit ADC as well as comparator, and we have operational amplifier also. This particular microcontroller is having actually mixed signal microcontroller, like digital signal as well as analog signal. So what is the biggest advantage of this particular series, and why I am going to introduce this as a course? I will tell you the reason. The main reason is these are the highlights. So if you see, this is a new low cost high efficiency ARM Cortex M0 Plus microcontrollers, very low cost and very new. So it can be run for, let's say, 20 years or 30 years from now onwards. Then this is having right processing and integrated analog features for any general purpose design that you want to design, okay, and the best thing is it has very reduced design time to get started early in the market, so you can put your system in the market very easily. and it is going to make the future of embedded possible with a scalable processing portfolio. What does it mean is, let us say you designed your microcontroller, let's say 16 pin microcontroller or 20 pin microcontroller. So same scalability you can do it for 32 pin microcontroller. Okay, so whatever the things that you have developed, it can be directly utilized in your next higher pin count microcontrollers in the same series. So if you see the portfolio, so this is the complete portfolio of MSPM0 series, so that is MSPM0L series and 0G series. Two series are there. So we have 32 megahertz, we have 80 megahertz, and we have 80 megahertz plus CAN. These are the legends that is there. So our aim is to go ahead with 20 pin package. So this is the three pins, three devices that is there, like 1304, 1105, or 1106, 1306. All these devices are there. So this we will be talking about. So any one of them if you design, you will be able to design almost whole microcontrollers. That's not an issue. Let me give you a little bit of features. Already you know, like what are the features of this. If you go to the data sheet, you will be able to find out these features. So the features of this is like it can work from 1.62 to 3.6 volt. So I will be taking 3.3 volt. Okay, and it has 12-bit ADC, and it has internal V reference. So you don't need to have, you know, like attach a V reference voltage for from external. It has general purpose op-amp as well. So that's the reason it is going to make your system design very low cost if you need one or two op-amps. Okay, and it has integrated temperature sensors also. If you talk about low power mode, so it is having just 96 microampere per megahertz in runtime. So you see, it is going to consume less than 1 milliampere of current, okay, when your system is running. So that's the beauty. If it is in a standby mode, it is going to consume just 1.1 microampere. Okay, now if you talk about digital peripherals, so we have a DMA controller, we have 16-bit general purpose timers, then we have windowed watchdog timer, we have 8 PWM channel. That's the best thing. So you can utilize these for, you know, like motor application also. So a small household motors, like we have lot of motor applications that we can utilize. We have UART, we have IRDA and DALI, okay, and then we have I2C, that is I2C application, SPI application. Those things are also there. Let us talk about more. So we have internal clock. Okay, so clocking system, you don't have to utilize external crystal or something like that for clocking. So it is having internal inbuilt oscillator. Okay, and it has internal LFOC also, that is low frequency oscillator also for your RTC timing. Okay, it has CRC inbuilt, so that's not an issue. Now it can give you up to 28 GPIOs. So if you talk about 32 pin IC, then it can give you up to 28 GPIOs, and it has 2 pin 5 volt tolerant as well. Okay, so if you have some 5 volt application, it can give you a capability to run that 5 volt tolerant pin. Okay, then we have just 2 pin will be utilized for your serial wire debug, that is your development support or programming thing. And our aim would be to take this particular device. We have other devices circuit also available, okay, but I will be giving you demonstration on this directly so that you can have a very good understanding and feeling how to input the circuit and how to approach for the design. Now if you talk about evaluation board, so this is the evaluation board that is there from Texas Instrument, and the part number for that is actually 1306. Okay, so this is by default I will be teaching you. However, this is the main thing that we are going to take into account. Let us talk about applications that we are going to see for this particular microcontroller. So these are the best thing that is there. So it can be utilized in your battery charging and management. Okay, so a small battery application or something is there. There you can utilize this particular microcontroller. Then we have power supplies and power deliveries like LEDs and all, LED drivers and all. We have personal electronics, we have building security and automations, we have fire safety alarms, we have peripherals and printers. Okay, so printers application also you can utilize. You can utilize in your metering or something, smart metering and all. We have communication modules. We have medical healthcare, like let us say very small application, SpO2 application, or maybe temperature sensing device. So those places you can utilize. We can utilize in lighting application also. These days LED drivers are coming, so these LED driver need some motion sensing or all those features. So to incorporate that, we have to actually utilize some of the microcontrollers. So these are the applications that we will be having. Okay, Good. So let us proceed to the very first thing. What we do in microcontroller design is we study the block diagram of microcontroller. So this is the block diagram of particular microcontroller that I am going to talk about. And as you can see, we have programming pin here. So let us say we have SWCLK, SWDIO. Then we have TXRX, that is my UART. So we have two UARTs, one UART 0 and one more UART 1. Then we have I2C, so one I2C application is there. Then we have timers and PWM. So you can see all these timers have the capability of PWM as well. So total 2 to 4 to 6 and to 8. So total 8 PWMs you can generate from this particular microcontrollers. Okay. Then we have a clock output, we have VDD, that is my power supply. So you can see we have VDD power supply as you put it. Then we have internal V boost, we have power on reset, we have brown on reset, we have linear, linear regulator or low dropout regulator. Then we have power management unit, and this power management unit will be responsible for supplying the internal circuitry power, okay, for this particular microcontroller. Then we have watchdog timer, we have op amps, and we have internal V reference. Externally, if you want, you can give V reference voltage for your analog channels or like ADC applications. We have ADC channels, so you can see 10 ADC channels are there. Then we have POKI, PICO, it is nothing but MOSI or MISO, okay, for SPI. So you know SPI we have four lines like MOSI, MISO, then MOSI, okay, then CLK, and then CS pin. Okay, so these are the things that is there. So SCK or something like that, it is there. We have DMA channel, we have CRC channel, and we have internal, like power, we have memories, and all those things are there. Alright, so with this we are now ready to go ahead and directly get into the design. So let us say we are going to consider the 20 pin device. So this is the device that we are going to consider, and as you can see we have this power pin powered from pin number 1 to 10 and then 11 to 20 pin number, okay. And as you can see, if you see color coding, so color coding is red one is actually power pin, so you can see it is power pin. The little bit bluish one is actually reset pin, so this is my reset pin, okay. NRST pin or PA1 is actually reset pin. The green one is 5 volt tolerant pin, okay. So these two are 5 volt tolerant pin, pin number 4 and pin number 5. So these things we will keep in mind and we will try to proceed for our design, okay. So let me give you an application which we are going to design. So the designing will be for this. So let us say this is my microcontroller that I am going to talk about, which is going to be MSPM0L1306, okay. Now how we are going to like connect all the peripherals, like let's say IR sensor or NTC, negative temperature coefficient sensors, we have pressure sensors, we have ADCs applications, we have reset switching, we have audio buzzer, we have temperature sensors, we have EEPROMs, okay. Like how to interface EEPROM, we have external interfaces. Let us say you want to run some other application board or something, and this is going to act as a master board and that will be acting as a daughter board, okay. So for that external interfacing we will do. We will also understand how to do the programming and programming connector interfacing. Then the best part is we will be seeing how to have general purpose LEDs and push button and dip switches for various applications, okay. Alright, so with this I think we are good to go ahead for our next session. So in the next session what we will do is we will try to develop this particular microcontroller symbol. So first will be my symbol. So I will generate the symbol of microcontroller and we will try to add my reset circuit and my programming circuit and my power management, okay. So power supply connector, power management, that is my LDO and something like that design, and then how it is going to be powered to the microcontroller and these reset and programming. So this is how my microcontroller will be ready to give a functionality, and then we will start with one by one other peripherals as well, okay. So if you do have any questions or any comments regarding this, any feedback, you please keep putting in the feedback comments and we shall be able to give you solutions as soon as possible. So alright guys, we'll move to the next session next time. Thank you.